Hello, I am Meet, and in this video, we will be taking a look at the weak package that will be introduced in Golang 1.24. Golang 1.24 is about to be released in February 2025, and there are some exciting things that are to be added in this release. Weak package is one of them. So, weak package is an addition to the standard library, and you can see that it is being now added to the standard library, which it was initially introduced in the internal library. So, what is a weak package? Weak package is a package in Go standard library that allows to create weak pointers. Now, a weak pointer is essentially a way to observe an object without preventing the garbage collector from reclaiming its memory. Now, that's a lot of mouthful there, but Go has garbage collector embedded inside its runtime so that it runs in the background and it automatically reclaims the memory of the occupied that are no longer being used in the program. Normally, if you have a variable that points to an object, that is, we call a strong reference, or you can say a strong pointer, that object cannot be garbage collected because that pointer is pointing to an object and hence it is being actively used in the program. On the other hand, the weak pointer does not prevent garbage collection. It allows you to check if the object still exists. If the object has been garbage collected, the weak pointer will be nil, indicating that it's no longer there. So a weak pointer lets you observe an object's existence without owning it or keeping it alive. Now, how is that different from a strong reference? So, both the strong and weak pointers are stored memory addresses of an object in the code. That is the only similarity that they have. There is a difference of which object's memory they carry and how the garbage collector treats them in this context. The strong pointer stores the memory address of the object directly. That is, it stores the memory address of the actual object that is referring to. Hence the name strong pointers or direct references. However, a weak pointer stores an indirect reference, that is, it stores a memory address of an object that in itself stores the memory address of the actual object, and hence the name weak pointers. Since it is a like since it is like a weak link or and not a direct linkage to an actual object, the weak pointer itself stores the memory address of a separate data structure called an indirection record. This indirection record then stores the actual memory address of the object. This extra step is why they call weak pointers. They don't directly own the object. Now, the garbage collector keeps track of the actual direct references and the weak pointers using a specific internal data structure with the help of unique pointers. The unique pointers are stored in a special area in heap which are accessible to the garbage collector. The garbage collector keeps the reachability based on strong references. If an object is reachable through a chain of strong pointers from root objects like global stack or stack variables, it's considered live and it will not be collected. So weak pointers are ignored during this reachability analysis. And in order to manage weak pointers, the runtime uses a data structure associated with each memory span. This structure holds like metadata about the objects within that span, including information about weak references. When a weak pointer is created, an indirect record is allocated in a special area of the heap, which is like separate from the main heap that the garbage collector manages directly. This special area is accessible to the garbage collector, and the address of this indirection record is what the weak pointer variable stores. So when the garbage collector determines that object is unreachable, there is no strong reference or direct reference that exists in the code. It uses the span metadata to find associated indirection records. It sets the memory address inside each of those indirection records to nil or an invalid value. This invalidates the weak pointer. It is crucial to understand that the weak pointer variable itself is not directly modified by the garbage collector. It continues to hold the address of the indirection record. However, because the indirection record now holds a nil address or a nil value, any attempt to access the actual object through the weak pointer will result in a nil result. So weak pointers are not necessarily stored on the stack, they can be stored on the heap as well. Now moving on to the actual weak package. It has two methods as you can see here. Two methods, that is that can be used to access or manage weak pointers. First, we have make. This is used to create weak pointers where from a strong reference, and the value method which will be used on that weak pointer, which could be used to check or observe the object. If it returns nil, then it means that the garbage, which means that the object the way to which the weak pointer was referring to was garbage collected, and if it was not nil, the object still exists and the value will be returned, but it won't be actual value. It will be a reference to the memory address of the object, and that is how it converts itself into an strong pointer after we call the value. And if you store the value of that, uh, the return value of this function, then and if we use that later on, that link becomes a strong reference indirectly. So as you know, the strong pointer will be the value, store its value as the memory address of an object that we will make it point to. So the strong pointer will have its own memory address as well, but it won't. But it will store the memory address of the actual object in its value. So the value that strong pointer variable will hold is the memory address of the actual object. So that is the fundamental thing to keep in mind here. And if we move on in the weak pointer, so in the case of weak pointer, we have an actual object that we want to have keeping track of that. So we create a weak pointer that will hold the value as the memory address of a unique pointer, and now that pointer will be storing the memory address of that actual object in its value. So weak pointer will hold the address of a unique pointer and the unique pointer address. So the unique pointer will hold the memory address of that actual object. So it's a linking of the actual object to the weak pointer via the unique pointer, and that is how the garbage collector efficiently can set the weak pointer to nil, as it identifies that any pointer, any direct reference, that is the unique pointer now will be a direct reference to the actual object. So if there exists, so without considering the the weak pointers, if it sees that there is no strong reference to the actual object, it will set the unique pointer to nil, because now that actual object is now cleaned up, and that is how the weak pointer will see the memory address as nil of the unique pointer, and it will say that the weak pointer has been nil, has been collected as well. And so how this works is, let's say there are some variables or objects or references, whatever you want to call it. So let's say there are the variables as x, I, and data, and the memory addresses of each of them are listed down there. So those could be any random values. Those are the memory addresses that actually hold that value, and the value will be itself any data type in Go. So in this case, x holds the value 98 as an integer, and I holds the value 0 as an integer, whereas the data holds the value list of strings, USD, INR, and EUR are strings, list of strings. So, and what garbage collector will do is throughout the program, the runtime of the program, it will keep track of where all these variables are used, and at a certain point, if any of the values are not being used later on, it will see that this value is now not reachable. We can clean the memory, and it will take the memory address of that variable, and it will free up that memory. That is, it will make sure that memory can be used again in the program. It can be used in the later stages of the program. So that is the thing again to keep in mind. And now, if you want to take a look into how the weak pointers will be used. So here now we have variables as ptr, ptr2, and data. So you can consider it as pointers and pointer2. So those are direct references to data. And now data holds some value. It could be a list of string as we saw. Now pointer is a direct reference to data. That is, it will point to data here itself. And a weak pointer will point to data eventually, but there is a middle value which will be unique pointer that will be set internally by the weak package, and it will be managed by the garbage collector to clean it up or not. And if we see that the direct references are no longer referring to that memory address or the data, then the garbage collector identifies that yes, this data was is now no longer being used. It will set the pointers. It will set the weak pointer address as nil as well. So weak pointer is not directly nil. It will go ahead and query the unique pointer, and if that the value of the unique pointer is nil, then the weak pointer will return nil. The value method that is available in the weak package, it will return nil in this case. So let's take a few more examples. So this is a simple example where we have a strong pointer referring to an referencing an object. Now I'm saying the 0x12345 is the actual memory address of that object. 0x56789 is the actual memory address of strong pointer, just to give a sense of what it is. So weak pointer now we want to refer weak pointer to the object. So how that will work is weak pointer will refer to unique pointer, which the unique pointer will now refer to the object. So you can see that all of them have own memory addresses, and once the garbage collector sees that at the end of, or at any point of time the object is being used, it sees that there is a strong pointer, a strong reference to the object via the strong ptr variable. It is safe, so it uh, keeps object memory as it is, and it doesn't touch any of the parts. And that's why unique pointer will still point to object, and that is how weak pointer will return the memory address of that object. And let's take one more example. So in the example 2, what we will do is that this will be the same thing, that is we'll point and strong pointer to an object, and we'll also have one weak pointer. And the third thing that we will have here is, let's say the third uh, step that we'll do is we'll remove the strong pointer reference. And at one point it was still referring to object, but now it is not referring to that object. So at this point the garbage collector will see that the object has no references, uh, has no strong references being used in the code or anywhere else in the program. So it will free up the space that object was holding. That is 0x12345 will be freed up, and it will be used later on in the program wherever it is needed. And that will do one thing, that is it will the unique pointer will was referring to object, but now it is nil, so it will the value will be nil, but the weak pointer will still hold the value of that unique pointer, and that will be nil. So the weak pointer will eventually be nil. So in the last example that we will be taking is, let's say we have two strong pointers and one weak pointer. In this case, let's say initially all are referring to one object, that is obj, and if one of them, if uh, if one of the two strong pointers becomes nil, you would see that there is still one pointer being referring to the object variable, and the garbage collector will see that there is still one pointer exists, and it will not clear up the memory for the variable object, and it will still survive, and it will still be used in the stages, in the later stages of the program. So weak pointer will return the memory address of the object. So let us start with the examples in the code. And what we need to do here is Let's start with a simple code, that is simple example. So that was to understand what strong pointers are. So let me create a simple struct user, and it will have fields like name with string, age with integer, and email with string. So now in the main function, I'll create an instance of this user struct. So this will be an instance of user struct, and we'll give it the fields respectively. That's the name, the age is integer, email is a string again. So this is the instance of user, and it's stored in the object. Now we'll create a reference of this object. That is, we will point this reference to the object using the ampersand operator. And this, what it will do is, it will simply uh, say that store the memory address of this object into reference. So now let's just print it out and uh, try to see ourselves what it actually means to create a reference from an object in Golang. So if we try to print the object's address, so you can do that via uh, percentage %p as a placeholder at the uh, type, and then use ampersand object to get the actual address of the object that we are referring to. And then for the reference, we'll do the same thing, that is the reference and the reference address. These are two different things, and we'll see in a moment why these are different things here. So I am using a printf because if you use print ln, that will just print out just ampersand and the actual object. It is not a really good thing to visualize what we are trying to do here. So let me just run this program, and you would see that object prints indeed the object, the actual uh, values that we are storing in the user instance, and the object address is some hexadecimal value with 0x as a prefix. And you will see that reference is actually holding a reference to the object variable here, and the reference address is uh, something different, and it is storing itself in a different variable. So there is a difference of the object's address and reference address. That is why we use these two as differently. Hello. So let us continue with by extending this example where we just created a struct for user, and we created an instance of this user struct using in the storing in the object variable. And now let us create weak pointers from it. So first I'll create a reference, that is a direct reference to the object by using ampersand object. This we discussed in the previous example. But now I'll create a weak pointer using the weak package. So I'll import the weak package, and I'll use the weak dot make. That will be a function that takes in a pointer variable. Sorry, a pointer like like pointer like um, type, and it returns in the pointer that we are looking for here, which is the weak dot pointer. So we'll pass in the reference. So we can pass it like reference, that is ampersand object, that is a strong reference, or we can directly pass in ampersand object. This is a preference, so you can go ahead with either of them. I'll stick with reference, and then I'll just print out the object and the reference and also the weak pointer. So that is, we'll do this thing first, and let us run this thing. So you could see that the object prints out the actual object, and the reference prints out the reference. So it is prefixed by a ampersand, so it indicates that it is a reference for the object variable. And then we print out the weak pointer, which in itself is not a direct reference to the object, but it actually returns the memory address where the unique pointer is being storing the reference for the object variable, so for the object reference. So that is that. And let us now also print the memory addresses for these all of the values. So for object, we'll print the address. So percentage %p will be used as a format specifier for printing out pointer like values or memory addresses, and we'll use ampersand n to get the address of object. Similarly, we'll do reference address with the percentage %p as a format specifier, and we use the ampersand reference to get the memory address for that particular reference memory address here. And then the weak pointer address will similarly do this with the weak pointer. And yeah, that is how we will try to print this now. So you would see here object address is now different from, so all of these are different addresses because those are uh, residing in individual containers and not like specific to these are not interlinked to any values. So those are separate, stored separately in each of the containers. And there is one more quirk about weak pointers, which I'll show it to you right now. So if remove one of the two fields here, that is, I'll only keep age here, and if this works out, sorry. So let us now try to do. So let's now try to get the actual working of weak pointers. So for that, we need to run garbage collector. So first let us try to get this reference as nil, because we need to now run garbage collector forcefully. So we'll say runtime.gc. So runtime.gc will uh, forcefully call the garbage collector here. And after we have called the garbage collector, we can now sort of see where these references and weak pointer lie. So this weak pointer will be storing what values, because now the garbage collector has run. There should be some differences in how these values are working. So if we run this program, and you would see that reference was indeed nil, but now the weak pointer has some memory value. But now, so we'll also try to print the weak pointer reference. So how we would do that is we get the weak pointer dot value, and you can see it is suggesting the other values as well. And now if you see that the reference is now nil, because the object is now garbage collected, because it was no longer used after we have called the garbage collector, which means after this call here, the object was never directly used. It was used via the reference, but reference was nil, and weak pointer doesn't stop garbage collector from collecting the values to the object that it is referring to. So that is the thing that I wanted to show here. But let me show one quirk about weak pointers. That is, so let's remove this for now and try to run this. In this case, since the references are still being used, that is, the object is being still utilized uh, in this code. Uh, it won't garbage collect this value, and hence the weak pointer still holds the value for the object that it was referring to. But there is one catch that we need to take care of. That is, like, let's say I just have one field in this, and that is specifically an integer. So now if I remove the name and email from these struct, and now user just has one field called integer, and if we try to run this, you would expect that the reference is nil, and so the garbage collector should collect the object value. But it seems that it has not collected, because it is still showing the age. The user's age is 30. And why is that case? Because here, since there is just one field of integer, and integer is 16 byte, we uh, we are not allowing the weak pointer to get dereferenced or get cleared out from the garbage collector. And this happens only for tiny objects it is referring to, that is 16 bytes or less. And integer Here is either 64 or 32-bit depending on the architecture. So it will usually be 8 or 4 bytes depending on the architecture, and that is why it doesn't clean up these values. As soon as I try to add one more integer, let's say it will be, so as soon as I add height here, and you can see that it got garbage collected, because now the uh, the the object size now becomes more than 16, because now it is 16, it is roughly 16, it is 8 and 8 bits long, because there are two integer values, and integer values are 16 8 bits. So that is why it gets uh, garbage collected as soon as, because this is not a tiny object anymore. So that is one quirk about weak pointers. It doesn't clears out values which are less than 16 bytes in total. So that is the thing. This is very basic toy example for uh, like weak package, and how we can interact with which package using the make and the value. The usual way to go ahead with this would be like, if weak pointer dot value is not null, then you can do sorts of things here. So as you can see here, we the correct way to do this will be weak pointer dot value, or if you want the actual value to be stored, you can use the value. So you can say str, sorry, strong pointer. So let's call it strong pointer. So you can see, you can print it out like this, or you can do some weird shenanigans over here. So you can call this values, and you can, so if you want to grab the value, you can do it like this, or depending on how you want to store this value, or if you want to use it in other places, you can pass this value and convert it into a strong pointer, because that once you access this gives back the unique pointer, and that unique pointer is now acting as a direct reference, so that becomes a strong pointer. And that it, if you use later on, it won't be considered for garbage collection by the garbage collector. So that is the way how we use weak pointers in a basic way. And yeah, let us move ahead to the next example. So let us start with the third example, that will be extending the first two examples. And third example will be from the references that I explained it earlier. So what we will do is we'll first create the object as usual. That will be the user object from the user instances from the struct of user. We'll add the fields name, age, and email respectively, and then we'll create references. So the first will be the ref, and it will point to the object. That is, it will be directly pointing to the object, and it will store the memory address of that object. We'll also create a second strong reference, call it as ref2, and this will do the same thing. That is, point to the object and store its memory address. So that way we have two strong references here, ref and ref2, and we'll create the third reference, which will be a weak pointer. So we need to import the weak package, and we'll call weak.make. This will take in a reference. So this reference is a memory address of an actual object that you want to point to via the weak pointer. So we'll call it reference, or you can also directly call ampersand object. That will basically get the memory address of that object. You can have your own preferences here, and we'll print out everything here, that is the object, the original reference ref, the second reference ref2, and the third reference ref3. But we also need to print the third reference value, which is a strong, sorry, it's a weak pointer, so we need to call ref3 dot value, which will grab the actual value from this. And if we try to run this program, so if you try to run this program, and you would see this, okay, I need to save the file. So let's save the file, and once we run this program, you would see all of them are printed the values, which is the original object, the original reference is pointing to that object, Second reference is also pointing to the object, but the third reference is a value. It is a memory address the of uh, of the intermediate unique pointer that will be used for the actual fetching of the object. And third reference is still pointing to the original object. So if we grab dot value, that will fetch out the actual value of this object. So we use value to get the object from the weak pointer that we are referring to. So so now let us print out the memory addresses of all of these references. So if you see, I add ampersand to ref2 and ref3, you would see that they are now printing out the memory addresses of where they are holding to. So these are all different memory addresses. That is, they are referring. So they are storing. So these are the memory addresses that in which the actual references is being stored. So those are the unique. So the for third reference, it is a unique. It is a actual memory address. So that differs from its actual memory address and the memory address of the unique pointer. So you would see that there are differences in the memory address that we printed out. However, the memory addresses that it is pointing to for the original reference and second reference, those are the same values because we are pointing to the same value, but those are offsetted by the integer values. And now let's simulate the condition, that is to make the references nil. And I'll need to simulate this condition to call the garbage collector. So runtime.jc will forcefully call the garbage collector, and let's print out all of these values: the original reference, the second reference, the third reference, and the third reference value as well. And I'll also call the object here, and yeah, we'll just set ref nil and not ref2 as well, nil as well right now. So we'll print out an object. But if you see and run this program, that you will see that this is all expected because we still have one pointer, one strong reference being referred to the object, and it should not be garbage collected. And that is why it is the third reference is still holding the value of the object. So I'll just call it garbage collected or garbage collector running, garbage collection running. So this will just say that this just indication where from where where. So this is just to print out clearly what happened after what. So you would see that the original object is still as it is. Original reference is nil, as you said it nil. The second reference is still holding the object. Third reference is still the same because it is still pointing to it, and the third reference is still pointing to the object. And now we set the reference to as nil. So and you would see the catch over here. So you can see that the original object is still there, which means it is not garbage collected yet. The original reference is nil, the second reference is nil. Third reference is still holding the object, which means there is no garbage collection done for the object. But the two references that we created are strong references, and now they are both nil, which means the object is no longer being used. But if you see carefully, the original object we have printed out the object, and that is an indication to the garbage collector that we are still indeed using the object in the code. So if we remove this line, that is the print statement, to print the object and run this program, you would see that it now is garbage collected. So the original reference will nil, the second reference will be nil, third reference will still hold a memory address, but the third reference value will be nil because it is the original object that it was pointing to, it is garbage collected. So that is the third example explained in a clear way. So the third reference value will hold the value it was originally holding, correct? So it is just it won't give out the values for those references. And now so that is the uh, how weak pointers work. and we saw the interaction of the two strong pointers and weak pointers in this example. And yeah, these are the ways where this is just an example. This is a little toy example, but you would see this being used in caching, canonicalization, or interning. So it is called as Golang. So that is how weak pointers work in Golang 1.24, and these at least for now. And that will be it from this what's new in Golang 1.24 series. We'll see you in the next one, and till then, happy coding. Thank you.